Welcome to Summarize Science, where today we explore a massive new study on how AI systems are learning to model the world. The researchers behind this paper are looking at agentic world models, which are systems that don't just generate text, but understand the dynamics of their environment. They explain that for an AI to actually accomplish goals, it needs to be able to predict what will happen after it takes an action. To help us understand this, the authors introduce a new way to categorize AI capabilities using three distinct levels. Level 1 is called the predictor, which simply learns to guess the very next step or frame in a sequence. Moving up, Level 2 is the simulator, which can plan out many steps at once to see how different choices might play out. Finally, Level 3 is the evolver, a system that can autonomously fix its own internal logic when it realizes its predictions aren't matching reality. The researchers also divide the world into 4 regimes that these AI models must navigate. These include the physical world of objects and motion, the digital world of code and software, the social world of human beliefs, and the scientific world of data. They analyzed over 400 different AI projects to see how they fit into this new framework. One interesting point is how they track the history of these developments from early mathematical principles to today's generative revolution. They show that while a model like Sora might look incredibly realistic, it still has trouble following the actual laws of physics. This is why they argue that looking real isn't enough, and AI needs to be decision-usable to be truly effective. The paper highlights common failure modes, such as compounding error, where a small mistake early in a simulation makes the whole future prediction useless. In the digital world, AI agents are learning to navigate websites and write code by simulating how different inputs will change the software state. In the social world, they are looking at how AI can model human theory of mind to predict how people will react in complex negotiations. The scientific regime is perhaps the most advanced, with systems that design their own experiments to discover new materials or biological structures. A key part of the evolver level is the ability to diagnose failures and update assets like skills and rules persistently. This creates a loop where the AI designs a test, runs it in the real world, observes the results, and reflects on how to change its model. They suggest that the future isn't just about making AI bigger, but making it more internally consistent with the laws of our universe. The researchers also provide a roadmap for building these systems, identifying major engineering bottlenecks like inference speed and data scarcity. They emphasize that we need better ways to evaluate AI that focus on the quality of its decisions rather than just how pretty its output looks. To summarize, the important points are that world models are evolving from simple predictors to complex simulators that can learn from their own mistakes. This means moving through 3 levels of capability across physical, digital, social, and scientific domains. By organizing these previously isolated areas of research, the paper provides a clear path forward for the entire field of artificial intelligence. What this means for the future is that we could see robots that understand the consequences of their movements better than ever before. We might interact with digital assistants that don't just follow instructions, but understand the logic of the software they are using. Most importantly, it could lead to AI that helps scientists solve our most difficult problems by autonomously discovering new laws of nature. The ultimate goal is AI that doesn't just predict what we say, but truly understands the world it lives in. Thank you for watching Summarize Science, and stay tuned for more deep dives into the latest research.